Okay, stop pleading. I'll go ahead and show you the other two ways. Okay, now the first way we did it was we actually broke it up into three separate triangles, and that was totally legitimate, but let's see if we can actually set it up in terms of side length. So I've gone ahead and designated this side over here x, okay? Now if I want to find an expression for x in terms of theta, basically I can use the law of cosines, okay? This is an oblique triangle over here, okay? And all I'm going to do is I'm going to use this oblique triangle in order to find a way of representing x in terms of theta. That's it, okay? And so I know that, remember that the law of cosines says c squared is equal to a squared plus b squared minus 2ab cosine c. In this case, c, obviously c and c is the opposite from angle c, and so what we're going to do is let's call it in this time it's x squared. X is our c, okay, and a and b are both radii. So it's r squared plus r squared minus 2r squared cosine of 180 degrees minus 2 theta. Well, if you do a little bit of simplification, it's really not that hard to show the fact that 2r squared, basically cosine of 180 degrees minus 2 theta is basically equal to negative cosine 2 theta. Okay, and all it would do is you basically just do the difference formula for cosine, but I don't want to take up too much room. And of course that negative is going to cancel with this negative, turning this into plus 2r squared cosine of 2 theta. Okay, now what we can do from here is we can do the power reducing formula, okay, and you can factor out the 2r squared and you get 1 plus cosine of 2 theta, and the 1 plus cosine of 2 theta, and I say power reducing and not double angle because 1 plus cosine of 2 theta is basically one step away from 1 plus cosine 2 theta over 2. Well, if I divide by 2, I need to multiply by 2. That right there, okay, is going to be cosine squared of theta. So all of a sudden you have x squared is equal to 4r squared cosine squared theta. And that means that x is equal to 2r cosine theta. Okay. Well, that's awfully nice. That means that I now have this side in terms of theta, this side in terms of theta, and I know how to represent that angle in between them in terms of theta, which means, remember again, one of the other formulas, and we've used it already in these videos, is the area is equal to 1/2 AB sine c, which basically means the two sides and the included angle. So area in terms of theta is going to be, and in this case it's going to be area is equal to 1/2 x times sine of 2 theta. But x and x are in terms of theta. We know how to represent those. And so what we get here is we're going to get 1/2 4r squared cosine squared theta, right? Because this right here is x squared, that expression right there. And then we're going to multiply it by sine of 2 theta. Sine of 2 theta. Whew. All right. Now, once we get to here, we can go ahead and, we can start pulling things apart and reorienting them and stuff like that. I want to take this sine 2 theta and actually represent it as, actually use the double angle identity. And when I use the double angle identity, the 2 from here is going to cancel out with the 1/2, and I'm going to get 4 r squared. Now remember, you're going to get a sine and a cosine, so you're going to get sine theta and cosine cubed theta. Now, that may look a little bit icky, but 4r squared comes out in front. It's basically just the chain rule inside of the product rule. So you have the first times the derivative of the second plus the derivative of the first, okay, times the second, or times the second. It's going to be to the fourth. It's not yet. Okay. Now, once I've gotten to here, okay, I can actually, basically fiddle around with this just a little bit in terms of actually finding. Basically, I need to let's just simplify, and then I'll explain it. Okay. We have cosine to the fourth theta minus, right? Because basically I'm putting this term first, minus 3 sine squared cosine squared, which of course means for r squared cosine squared theta, 1 minus, or not 1, cosine squared theta minus 3 sine squared theta. Okay. Well, cosine squared can turn into 1 minus sine squared, and so I can go ahead and change this again into 1 minus 4 sine squared theta. And now I have a derivative that's actually factorable. I'm going to go ahead and set cosine squared equal to 0. Now remember, this is the difference of two squares. 1 plus 2 sine theta and is equal to 0, and 1 minus 2 sine theta is equal to 0. Alrighty, so where is cosine theta equal to 0? Well, cosine theta is equal to 0 at pi over 2 and 3 pi over 2. Well, for our scenario, neither of those are going to work. This is going to give us sine theta is equal to negative 1/2, and of course that happens in the third and fourth quadrant, right? So that's not going to help us. But sine theta is equal to positive 1/2 happens in the first and the second quadrant, and the first quadrant value happens to be pi over 6, or 30 degrees. Oh my gosh, that's exactly what we got when we did it the other way. Yay us! But wait, there's more. We're going to do it by Heron's area formula. Alrighty, are you ready for this? This is going to be truly fun. Alright, so if I'm going to do this, and I basically set it up roughly the same way, I have x, I have x, I have y. Okay? What I need to do is I need to figure out a way, because I need the semi-perimeter, right? I need to represent both x and y in terms of theta. Okay? Now, I know that this right here is going to be 1/2 y. I know that this is r. I know that this is r. If I go ahead and, draw the sort of perpendicular altitude to here, I'm going to get x over 2. And basically what I need is I need to figure out ways of representing. Well, I can just use right triangle trick, right? Because this is a right triangle and this is a right triangle. And so what I have is sine of 2 theta is equal to y over 2 over r, right? So opposite over hypotenuse from this 2 theta right here. I also have cosine of theta from this theta right up here is adjacent over hypotenuse, or x over 2 over r. Now, if I do a whole lot of finagling, what that basically gives me is y is equal to 4r sine theta cosine theta, and x is equal to 2r cosine theta. Now, from here, we need to find the semi-perimeter. Okay? Well, the semi-perimeter is half of the perimeter, so it's going to be, right? It's going to be x plus y. So 2r cosine theta plus 2r cosine theta plus 4r sine theta cosine theta, and of course it's not the perimeter but the semi-perimeter. Well, that makes basically these two together are 4r cosine theta, and of course that means that I have a 4r cosine theta that can be factored out, and what I'm left with is 1 plus sine theta, all of that over 2, or just change that bad boy into a 2, and so basically that's my semi-perimeter. Okay, now I can also, 2r cosine theta plus 2r sine theta cosine theta, when we start subtracting underneath the radical, that might be a better form to use. So let's do it. Remember that when we're doing Heron's area formula, the area is the square root of s minus a, s minus b, and s minus c. Okay, so in our case, it's going to be the square root of the semi-perimeter minus x, semi-perimeter minus x, right, because two of the sides are necessarily the same, and then the semi-perimeter minus y. And we have all of those in terms of theta. So our area is going to be the square root, okay, of, and let's go ahead and do it, let's do the s in factored form. So 2r cosine theta and 1 plus sine theta. So this right here is my s. Now s minus a, or s minus x. Now remember x, I'm going to go ahead and write them over here so we remember. Y is 4r sine theta cosine theta, and x is equal to 2r cosine theta. So if I was to actually subtract x from this version, s minus a is just 2r sine theta cosine theta. Okay, twice, because obviously s minus x is squared. So this right here is s minus x times s minus x. Now all I need is my s minus y. S minus y is going to be turned basically this 2r cosine theta plus 2r sine theta cosine theta into minus, okay? Which would then, of course, factor into 2r cosine theta and 1 minus sine theta. Okay, so this right here is a factored form of s minus y. Now notice this is already squared. These two are the same, and when I combine 1 plus sine squared and 1 minus sine squared, I get 1 plus sine and 1 minus sine, I get 1 minus sine squared, which by Pythagorean is cosine squared. Okay, so I realized that by some stroke of luck, I have everything under the radical is squared. Okay, so basically what I have is I have the square root of 2r cosine theta squared, 1 minus sine squared theta, which is going to become cosine squared, and 2r sine theta cosine theta. Like I said, this becomes cosine squared theta. Everything under there is squared, and therefore I'm just going to get, in terms of a simplified version, I'm going to get 4r squared sine theta cosine cubed theta. Oh my gosh. That looks awfully familiar. That looks like this. So I won't go through the differentiation again because this matches that, so its derivative and the critical values for that derivative will match. But see how with Heron's area formula we got to the same exact place, and therefore we'll get exactly the same solutions. Now, for those of you who wanted to see the video and actually got to the end of it, kudos. This is sort of a bonus video that I didn't expect to do, but there you go. If you have any questions, please do shoot me an email. Bye.